So today we're going to learn how to convert between the four quadratic forms that we learned about on Friday. We are going to start with an equation of a parabola written in x-intercept form. We're going to have y is equal to 3 inside of the first set of parentheses, x plus 2, and then inside of the second set of parentheses, x minus 1. Now, our first goal is going to be to convert this to factored form. Remember that factored form is what it looks like when it's two lines being multiplied together. So basically, we need to get rid of that stretch factor out front. We have two different ways we can do this. One, we can either distribute the 3 into the first set of parentheses. If we do that, we end up getting y is equal to 3x plus 6, and then this x minus 1 stays by itself. Or we can choose to distribute the 3 into the second set of parentheses. So the first set of parentheses would be left alone, it would stay as x plus 2, but then this set of parentheses would become 3x minus 3. Make sure whatever you do though that you don't distribute the 3 into both, otherwise you're really multiplying by 9 because you're multiplying each one by 3. Now, to get into standard form, we're really just multiplying two lines together, so you can do any of the four methods that we learned earlier last week. We had the area model, the standard algorithm, the distributive property, or FOIL. And you can choose to do either set of parentheses for the factored form, so you could do the 3x plus 6 times x minus 1, or you could do the x plus 2 times 3x minus 3. I will do the area model, and I will just do this second set of parentheses over here because it's the closest one. So I have an x and a positive 2, and I have a 3x and a negative 3. I fill this out. This first box is 3x squared, and then I have a negative 3x. I have 6x and negative 6. Adding all of these together, I get y is equal to 3x squared. 6x and negative 3x together make a positive 3x, and then I have minus 6. Now, to put any of these forms into vertex form, we first have to be able to find the vertex. So right underneath where it says vertex form, you should have a spot that says to find the vertex, 1 or 2. We're going to learn two different methods for finding the vertex. The first is a formula. To find the x-coordinate of the vertex, you're going to use the formula negative b over 2a, and then you plug that back into your equation to find the y-coordinate of the vertex. Now, you may be thinking to yourself, what are b and a? Well, remember that a is the coefficient of the x squared term when in standard form, and b is the coefficient of the x term in standard form. C is technically this constant, but we don't really need to know that to find the vertex. The other way that you could find the vertex is you could find the average of the x-intercepts. This is because we know that the parabola is going to be symmetric and the x-intercepts would be evenly spaced on either side of the vertex. So let's go ahead and try this with the standard form equation that we have written above. So the x-coordinate of the vertex is going to be negative b over 2a. Well, b in this case is 3, so negative 3 is negative b, and then we have 2, and then we have a, which is also 3. So if we simplify this, we get negative 3 over 6, which is the same thing as negative 1/2. Therefore, the x-coordinate of the vertex is negative 1/2. To find the y-coordinate of the vertex, we plug this back in to our equation for x. Now, technically, it doesn't matter which of the above equations we use. We can use any of the three, I guess technically even four, with both factored forms, equations that we have. I usually choose the x-intercept form or factored form because it's usually the easiest, especially when dealing with fractions. So, I'm going to have y is equal to 3, and then inside parentheses, I'm going to have negative 1/2 plus 2. And then inside the other set of parentheses, I'm going to have negative 1/2 minus 1. Now it just becomes PEMDAS. So I have 3, and then negative 1/2 plus 2 is the same as 1/2, which is really 3/2. And then in the other set, negative 1/2 minus 1 is negative 3/2. If I multiply across, I have 3 times 3 times negative 3, which is negative 27. Over, on the bottom, I have 2 times 2, so 4. Now, I can plug this back into vertex form that we learned last week. I have y is equal to the stretch factor, which is 3. Then I have x minus the x-coordinate. If I'm subtracting a negative 1/2, that's the same thing as adding 1/2. And then I have squared, and then I have adding the y coordinate of the vertex. So minus 27/4.